Welcome back, crew. This is lesson 3 of my Scratch class. We are going to gain control over control blocks today, and we are going to learn about variables, and we'll make a game using those two things. Let's take a quick look at the looping blocks that they have in Scratch. There's the repeat a bunch of times, there's the forever loop, and then there's a repeat until. And you actually know looping already. I'll tell you why. Because if you tell somebody you're going to give instructions for someone to go walk to the bathroom, you wouldn't say, turn left, then step again, then step again, then step again, then step again. You wouldn't just do that endlessly. You'd say, you walk until you get to the first door on your left. And so that's a loop. That's a loop that's a repeat until loop. You're saying, step until you see the door on your left and stop stepping. Now, let's look at each of these loops more closely. Let's pretend that there's a Scratch block that I made up called
Swing a Hammer.
Let's try hammering the carrot into the table using the repeat. This time we're going to say 5 times. Let's try hammering that carrot into the table until some condition is true. And that condition is the height of the carrot over the table is 0. Let's try the forever loop and see what happens, where it just never stops. Should we look at a preview of the game that we're going to make today? I think we should. Let's look at it. Some jerk has cut all the animals in half. Your job, connect the animals. Properly, please. So you control the front end of the severed bear, and every time you connect to the back end, you make a full bear and you get a point. But if you connect to the wrong back end,
game over.
You know what time it is? It's time for Geek of the Week. Born in 1815, Ada Lovelace was the world's first programmer. She was also known as the Enchantress of Numbers. She worked with this other smarty pants whose name was Charles Babbage, who designed a machine that was the first computer, really. It had cranks and wheels and stuff like that. But Ada was the one who saw how this machine could be used to program any ding-dang algorithm you want. Eventually, they named a programming language after her. They called it C++. Okay, they named it Ada. Some say she's still alive and she lives with Elvis. Do you guys remember last time we started with stealing stuff from me? Steal stuff from me again. Go to Tskolnick, Tskolnick, and go to the Cleveland Sprites program and click Remix. And inside of there, you're going to find the sprites and the backgrounds you need that are going to save you a ton of time. So let's look at the sprites we have. See, it's a few costumes. There's back end, severed back end, a couple walking positions. There's elk or something. There's a severed elk and a couple walking positions. And then there's the front side of the bear. And then there are a couple backdrops that you're going to need. Imagine you had a box, and you could put a number in that box. And when somebody asks you, hey, could you get that number out of the box? You go to the box, you get the number out. And you had a whole bunch of these boxes, so you got to label them. You put a name on the box, you write score on the box, and somebody says, hey, what's the score? You go to the box, you take out the number, you say, oh, the score is 5. And if you want to change the score, you throw the 5 away and you put a 6 in there. That's a variable. If you want to learn more about variables, that's kind of a waste of time. I already had the variable score in there, so I'm going to delete it and then create a new variable and type in the name score. And I spell it the way Americans do, S-C-O-R-E, as opposed to the British spelling, which is S-C-O-U-H-R-E. You. Okay, crew, you know what I'm going to do? I'm going to speed up a section where I do some programming. I'm going to tell you what's in there, and you can pause and look at each part of it. We're going to start by programming this stage. When the green flag is clicked, we're going to set the score to 0, because now that we have a variable for score. Then we're going to switch the backdrop to the intro. Then we're going to wait for 1 second for you extremely fast readers. We can change it to 5 seconds after we got the whole thing working. We'll switch the backdrop to the play backdrop, which is just pure white.
Like the driven snow.
Which will make the severed animals show up nicely. You know, if your program has left a sprite hidden and you want to see it again, you just come over here. Look, there's a little eyeball over here. You can hide and show the elk butt. or any sprite really. It doesn't have to be a butt. And so if your code has left it something hidden, you can click that button and show it. Okay, but now let's get to the matter. When the background changes to the play background, this elk butt has to start running across endlessly. First thing it has to do is show itself, because remember, it was hidden at the end of the green arrow event. If you remember from the last, the Cartesian coordinates bit, negative 240 is the left-hand side of the screen. And then I need to pick a random number between negative 180 and positive 180, because that's the range of y values. And that will, if I pick, using the pick a random operator, you can pick between any numbers. And you're familiar with this. Pick a random number between 0 and 10. So this is negative 180 to 180, and what that bit's going to do is going to start him off somewhere vertically along the y-axis, because, it's not a game if it's always the same spot. After we go to the left side of the screen and choose a random position vertically, then we're just going to have a forever loop that will move 10 steps at a time, which is the bit that's going to help him walk across the screen. So then we're going to move 10 steps. I think we can run this, and the elk butt should show itself. Okay, it's zipped across the top, and that's perfect. This elk is zipping across the screen. Now all we have to do is change its costume so it looks more prancy. We just have to keep saying next costume. After each costume change, we need to make it wait just a little bit so that we can see the costume. 0.1 second is the proper amount of time to wait for an elk. If it were a llama, it would be 0.15. Look at it. Look, it's prancing. It's going to look like there's endless elk butts coming across. When the elk gets to the right-hand side, what we're going to do is send it back to the beginning. So the first thing we have to do is detect when it gets to the right-hand side. And to do that, we need an if statement. Then we're going to say, if you're at the right-hand side, then go back to the left-hand side. If you remember, because you paid such close attention to the Cartesian coordinates thing from last lesson, the right-hand side of the screen is x equals 240. So you're going to ask, when my x equals 240, then we're going to do something. You'll see, it's going to be very clear what we do. So we have the if statement from the control blocks. We're going to check the greater than operator. So if x is greater than 240, which means you got just past the right-hand side of the screen, then I just need another copy of that. Go to the left-hand side of the screen, which is negative 240. Pick a random position on the y-axis between negative 180 and positive 180. So let's run this. Cruise across the screen. We check when our x is greater than 240. If it is, we go back to the left-hand side and choose a spot vertically using the random number operator. Thespian. All that's left for the elk butt is to detect when it's hit the front of the bear. So we're going to have another if-then statement. If we are touching the front of the bear, then we'll show the backdrop that says game over, and we'll stop everything. Let's go to looks, switch the backdrop to game over. There's another block that will just stop everything. Where is that guy? Control, probably. Control, stop, all. I like that. Let's play. Okay, we will cause a collision. Elk butt, bear front. Just drag that thing down, and game over. Uh-oh, the elk butt is still showing. Let's solve that really fast. We will solve that with an event. When the backdrop switches to game over, we want to hide because we only want to see the backdrop. We're not ashamed, but we're going to hide. Sometimes you just have to hide. Bears and llamas are pretty much the same. They've got legs, they live outdoors, they've got two eyes. And so that means when they get to the right-hand side of the screen, they come back to the left-hand side of the screen. So the code for the first part of the bear is just like the llama. Let's fly through it. Look, now this is where I discovered that I didn't put the show in. Where's the back of the bear? Where is it? Okay, the bear butt, it's got 3 costumes. One's the full bear and 2 butts. To make the bear walk, we just switch between costumes 2 and 3. And if then else control block is going to do the trick. If you're in costume 2, you change to costume 3. Otherwise, you just change back to costume 2. That and a short wait, and it will just be switching back and forth between costume 2 and 3. And boom. Okay, let's take a closer look at the if then else block. I want to make an if statement that says, if we're wearing costume 2, change to costume 3. To do that, I grab the equals block from the operators blocks and the costume number block from the looks. I'm just going to reorder the if blocks for a moment here. If it is true that we are wearing costume 2, then we'll use the switch costume block to set us to costume 3, which is the Bear Walk D costume. Otherwise, we'll just switch back to the Bear Walk C costume. Then we put in our weight block, put in 1/10 of a second so that we can see the costume changes. I want the sprite to move faster, so I'm going to change the step size. You might say, hey, Dad, why is that? I'll tell you why that is. Imagine you got 2 sets of fingers walking across the table, and they take the same number of steps per second, but one of them takes big steps and one of them takes little steps. The one with the big steps, it's going to go further. It's going faster. Let's take bigger steps. Our sprite's going to go faster. Oh, this is great. Look how fast they are. Slow down, you're too fast. You know what we didn't check yet, which we have to check right now? We have to check what happens when the back of the bear touches the front of the bear. That's when you score a point. If the back end of the bear is touching the front bear, we're going to change the score by 1. So you just scored a point. Well done. Let's give this a run. We'll just move the front of the bear so it connects with the back, and we'll watch it change the score. And there we go. When we connect a bear butt to a bear front, we incremented the score, which is good. Then I want to wait for just a second, and I need to send the bear back around to the beginning, so we have a chance to score again. So let's run it, and there we go. I think we have reason to be proud at this point. Nobody can take that from us. We still haven't flashed the full bear for that satisfying, completed bear feeling, but we're about to. So we're going to have it like a ghosted effect. We're having it a 50% translucent bear, so it's. I just like the way it looks. So we're going to switch the costume to the full bear costume, and then we're going to show the ghost effect at 50% so you can be a kind of a see-through bear. And so, it's just awesome. That's all. Oops, I hit the I hit the llama. Oh, no. Okay, avoid the llama. Good. Oh, but look, I'm stuck in ghosted mode. I don't want to be in ghosted mode all the time. I just want to be ghosted for that moment when I show the full bear. So I think I can, at the top of the loop, I'm going to clear the visual effects to make it, the ghosting gets cleared. Okay, I have a full opaque bear butt. When it hits, oh, look, it flashes. That is so satisfying. It flashes a full bear, and it increments the score. We're like professional game makers here. You know what we need to do? We have to move the front bear. I forgot all about the front bear. The front bear has to be able to move up and down with the up and down arrows. I know that when you hit the up arrow, we're going to have to change the Y position on the bear. And so we're going to do a go to, and we're going to keep our current X position. So I know I need to toss that in there because we only want to move vertically. For the Y position, we're going to do whatever the current Y position is minus 10 or something. That if you subtract 10, it's going to move up. Or if you add 10, it moves up. Oh, if you add 10, it moves up. Did I do it backwards? Let's find out. Yeah, the Y's get larger as they go toward the top of the screen, as they go north. Let's see if I got it backwards. If I did, we'll straighten it out. I'm not scared. It don't scare me none. You know what? Graphically, I like having the up arrow set of blocks above the down arrow set of blocks. Don't you think that's easier to read? Look, press the up arrow, down arrow. That bear is moving up and down. Okay, we worked hard. Let's play. Let's hit the play button and the get bigger button. We know the intro. Blah blah blah. Let's play. Oh, I scored a point already. I scored a point. Okay, get that bottom bear. Oh, I missed it. Get that middle bear. 2 points. Get the bottom bear. 3 points. And yeah, avoid the elk llama. And avoid. Come on, move. Ah, game over. So you see the problem there? The problem is that those 2 sprites remained. We got to make those sprites hide. And I'm going to show you how. This is going to be easy. So when the game is over, we detect it by the event. So the background change event. When we see the background change event switch to game over, then we will hide the sprite. That's all there is to it. Okay, there's that. And now under looks, we hide. And here's the little trick. You can grab that that little block of code and drop it on another sprite, and it will actually copy that block of code to the other sprite, because we want all the sprites to hide when the game is over. And so there you have it. We're great. We're heroes.